Hello, my name is Katie Perkins, and this is my presentation for Physics 2 Lab 2, Lines of Charge. The purpose of this lab was the same as Lab 1, except this time we're improving our understanding of charge distribution by representing the tape as a line charge rather than a point charge. The goal was to determine the amount of excess charge on one piece of charge-clear tape using the more accurate assumption of a line charge. To summarize the results, when the gravitational force and electrical force equaled each other at a value of 1.96 times 10 to the negative third, the charge of the line had to be equal to 2.54 times 10 to the negative eighth coulombs. The relevant physics concepts were the same as Lab 1, with Coulomb's law describing the force between two electrically charged objects and the gravitational force being equal to mass times acceleration due to gravity, and Newton's first law stating that the sum of the forces must be equal to zero when an object is in equilibrium. For the experimental model, we use the same model as Lab 1, with Part 1 being making a charge tape, then observing the U-tape interactions, then estimating the excess charge. In Part 1, we made a charge tape. We did this by laying down a bottom piece of tape on a hard surface, laying another piece of tape on top of it, this time with a small handle on it and with a marking U, then holding down the bottom tape and ripping off that top tape to charge it. In Part 2, we observed this new U-tape interactions. So we made two identical U-tapes in the similar method as Part 1, and then we observed how the two U-tapes interacted when they were brought close together. We noticed that they repelled each other, noting that they have the same charge. Then we observed the U-tape interaction when brought near neutral objects like a wooden block, in which case we noticed they were attracted. Then we rubbed a plastic pen on some cloth, thus negatively charging it, and then brought it close to the U-tape. We noticed they were attracted, therefore the U-tape is likely positively charged. In Part 3, we estimated the amount of excess charge. We did this by making one U-tape and securing it between two objects of equal height. We made sure the tension wasn't too tight. Then we brought our second U-tape underneath that first U-tape and slowly moved it closer until the top U-tape began to float. Then, right when it began to float, we recorded the distance between the two tapes at that time. We noticed that they began to float 2.5 centimeters away from each other. The calculations for Lab 2 were essentially the same as Lab 1. I assumed that each U-tape has the same net charge, and I ignored the effects of air resistance. To find the gravitational force, I first found the mass of one 20 centimeter long piece of tape. Then I multiplied that by the acceleration due to gravity to find a gravitational force of 1.96 times 10 to the negative third. Then, as a reminder, I put my calculations for the tape as represented by a point charge by setting the gravitational force equal to the electric force, and that was found to be 1.17 times 10 to the negative eighth coulombs. The summary of results are as followed. When represented as a point charge, the charge of the tape was 1.17 times 10 to the negative eighth coulombs. Again, the gravitational force was 1.96 times 10 to the negative third newtons. The tape began to float when they were a distance of 0.25 meters or 2.5 centimeters away from each other. Using the assumption of a line charge, when the gravitational force and electrical force were equal to each other at a value of 1.96 times 10 to the negative third, the total charge of the line had to be equal to 2.54 times 10 to the negative eighth coulombs. The sources of error were likely overhandling of the U-tapes, unequal charge distribution on the two U-tapes, too much tension on the hanging U-tapes, and inaccurate gravitational force estimations due to inaccurate tape pulling. For my glow script modeling, I first started by putting in all of my constants, as well as the initial guess that my charge of a line was equal to my point charge, 1.17 times 10 to the negative eighth. Then, I plugged in my function that I developed in Lab 0 to find the electric field. Then, the tape was represented by a series of spheres. A function was used to add together all the different electrical forces between each individual small piece of tape. Finally, we made arrows to represent the gravitational force and the sum of all the individual electrical forces. On the left, you can see when I started with my initial guess of the point charge, my gravitational force was way bigger than my electric force. Thus, through a process of trial and error, I adjusted the charge Q until I found when they were equal to each other. This happened when the line charge was equal to 2.54 times 10 to the negative 8th. Thank you for listening.